Seeing it a second time this morning. All right, so Harlan was out yesterday. Kaylin was out yesterday. Is that right? All right, they're giving you this first graph they want you to draw. This is just your base, your parent graph. You got to know what sine x looks like, Harlan. So sine x looks like this. You need to memorize it. Draw that. So every problem that we have that starts off with sine x, like number 3 and number 5, you're going to draw this first. So you're going to have at least 2 graphs on each problem, and sometimes 3 or 4 graphs on a problem, depending on how many adjustments we have to make. All right. Harlan, Kaylin, we good so far? All right, now Harlan, we're going to find our 4 answers for this new problem. Okay, and it's just like what we did on the other side of that worksheet. Amplitude is 3. You go ahead, Garrison. Period. 2 pi over 1 is 2 pi. How do I know there's not a phase shift? And location change is up 2. So this is why y'all had to learn all this stuff on those other sheets, so we can graph it on this sheet. Not a phase shift. And how many adjustments are we going to have to make on this problem? 2. Why don't we have to change anything on the period? Because look, the first line I drew, Harlan, the length of it was 2 pi. This graph, the length is going to be the same thing. So we don't have to change that. I'm not even going to worry about that. We got to change location change and the amplitude. Okay, if you were here yesterday, where do you start if you have to change more than one thing? Start in the back and go to the front. We're going to change this first. Location change. All right, so all this means, if the location changes up 2, guys, take your graph, just slide everything up 2. That's all it means.
Except for the 3 points on the axis, right?
No, you actually slide those up 2 also. Now, what I want you to do first, in a color, draw me a dotted line up 2. This is going to be our new x-axis. And now, Harlan, I'm going to take every point and move it up twice. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. And look, it should make the same shape that you had. We just slid the whole thing up 2 spaces. Okay, now the last thing we have to do is change the amplitude. Since this is our last thing we have to change, this is the one I want you to draw in your color. Because your last answer should be in your color. That should be the only one I have to grade. Okay?
Wait, so we weren't supposed to do all that in color?
That's okay. It doesn't matter if you did. From now on, the last one you draw, I only want one graph drawn in color. So I know that's the one I got to grade. It'll help me find it quicker on text. All right, so Harlan, amplitude. What it means is the 3 dots right here that were already on the dotted line, you don't move those ever. You leave them. And what it means is, Harlan, we're going to multiply by 3. Well, since these 3 dots were on the x-axis, that's 0. It's like times 0 by 3. It's still 0, right? So you don't move these 3. But Kaylin, instead of going up 1, you times it by 3. 3 times 1 is 3. So now you go up 3 spaces. 1, 2, 3 right there. And this one down 1, 2, 3 right there. This makes your new graph. Now we're done. That one goes in color because it's your last one. That should be the only one I have to grade.
What by 3? The original?
Places where you went up 1 space, Harlan, if you times it by 3, it's going to make you go up 3 spaces now. I mean, it would have been the same if you did it on the original because they were only going up 1 space on the original too.
I was just confused about the one.
Wait, so, okay, will the part that goes down, would that be even with like -2 or -1?
Negative 2.
Right here, you mean? Going down 1?
Yeah, would it be?
So times it by 3, and now you go down 3.
And you start on the x-axis, don't you?
Hang on, Hayes. Matthew.
You start on the x-axis.
We start on the x-axis. Yes, you count from the x-axis. Now we're counting from the dotted line. That's why we drew the dotted line, so we got a place to count from. You count from your new x-axis. Again, that's why we drew the dotted line. Hayes.
So if it was like two spaces, it would turn by two from the dotted line.
Yep, from the dotted line, 1, 2, I'd go to there and put a dot. So the amplitude, you just count from the dotted line.
Okay, I count from the original dot.
No, you don't want to count from the original. That's why we moved everything up 2.
So we don't.
Oh, you counted from the old dot that was already there. You counted up 3. No. Go back and count from the dotted line. Harlan?
We're multiplying.
Multiplying it by 3, basically.
Well, we always just can go up by 3, or whatever the amplitude says.
Whatever the amplitude is tells you what to go up by.
We're just gonna go up by that?
Yep. Except for the ones that were on the x-axis, they stay. And the reason you don't move those because 2 times 0 is 2.
Is it always gonna be the same?
Sorry, 2 times 0 is 0, so you wouldn't move it
Is
up.
the
Harlan?
original thing always gonna be like that for sins? Or are you gonna
Yes,
add it?
yes. Let's do another one. I think the more we look at, the easier to get. Number 2. All right, this time Harlan and Kaylin and anybody who was out yesterday, this time we have a new problem. We've got cosine x. All right, so you also have to know what this one looks like. Starts at 1. All right, those are your 5 points. Now, it does not make a V. Remember, I said yesterday it's like handlebars on a bicycle, right? It's curved. Now, that is your base graph, your parent graph for cosine. Those are the only ones we're going to do. We're not going to do tangent or secant or any of the rest of them. We're just going to do sine and cosine. Guys, we're just starting this stuff. It's okay if you're confused. What in the heck are you doing with that cup?
I just
What
grabbed
in
one.
the heck? Oh my gosh. Garrison, look at this. What the heck?
I literally just grabbed
Oh
it.
my
Hey, it
goodness.
was in
What's that
Reggie's-
doing in your house?
It was in Reggie's cabinet, not mine.
Why-
Dallas
why
gave it
Reggie
to
got
us.
that?
Getting that man.
All right, here we go. So now find your 4 answers, Harlan. Harlan, help me right here find my answers. What's my amplitude going to be for my new problem? 1, period. That's a 1. The formula is 2 pi over k. So 2 pi over 1 is 2 pi. Now there is a phase shift this time. How do I know? Because I got parentheses. Now first block forgot how to do the phase shift. If y'all need to go back and look, we just did it right here. Phase shift was negative c over k. So we took this, put it on top, divided it by that. All right, so now let's go back and look at what we've got. Well, next one. Where am I? There we go. Phase shift. So on top we put negative 3 pi over 2 and we divide it by 1. That's going to be negative 3 pi over 2. Not a location change.
Hey, Coach Eric, you got a black Sharpie rather than
Yeah, we need to. All right, so guys, there is only one thing that's going to change on this problem, Harlan. We only got to make one adjustment. We have a phase shift. We didn't have one before. Look, that's the same. Our first graph was 2 pi. This one's 2 pi. I don't have to worry about that. And the amplitude was 1. How do I know? Because they went up 1. Right? I don't have to worry about that. We only have to do the phase shift. That is it. That is the easiest one. Watch how easy the phase shift is. All you have to do is shift it either forwards or backwards. They want us to shift it to negative 3 pi over 2. So Harlan, it's like taking this whole graph and just sliding it this way. That's all you got to do. So our answer is going to start here, go here, go here, and draw the same exact shape you had. We just slid it over. That one needs to be drawn in a color because that's the only change you got to make on this one. So that'll be your final answer. So again, I'm only going to have to grade your paper. Just look for the ones in color. Yes, I should be able to grade it pretty quick. All right, I want y'all to start on number 3. It's a sine problem. Go back and look at number 1 Harlan, if you got what a sine looks like. Good. Let's go sine x over 1. Now, got to do a common denominator on the bottom.
Yeah, we're doing one
So,
side.
draw a fraction on it. What's your common denominator go to? Goes to the bottom of the fraction. Now, got to do a common denominator on the bottom. So, 2 times 2 is 4. 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 2 times 2 is All right, we're on 3. All right, sign X. We got to do that first. So I'm assuming everybody can draw sign. All right, we're good there, right? Good on that part? All right, Kaylin, help me out on my 4 answers for this problem. What's my amplitude? 2, period.
I didn't do it.
All right, look, it'll be 2 pi over 2, so it's pi. There's not a phase shift and there's not a location change. Check that, make sure you understand where I got those 4 answers from.
Yeah, so we got the, move it up to, and then shrink it.
All right, hold on, time out. We've got to do 2 adjustments.
Shrink it first.
Remember, you start from the back and work your way to the front. Yes, sir, what y'all bringing me?
Oh, God.
You got going on with your board.
All right, so what happens? I'll be middle of class. Now, what I like to do, see, look, Mr. Marty, I like to save all my stuff all day so I don't have to rewrite. So what will happen, I'll be in the middle of a problem, it just completely shut down, restart, and wipes all this off. Now, what I've started doing, I've started saving it, but it's still a pain. So if there's a way we could get it to hold more storage, or where I could write more stuff, use more pages, would be great. I
He
don't know.
needs to be on, that software. You need to use the whiteboard on the computer.
Yeah, it's the same thing, but it's.
Why don't y'all come by and show me 4th block?
We-
Is that all right?
He can come by right now.
There's a math.
He
teacher.
can
No,
do it
no.
right now.
Hey,
She's in middle school.
You wanna
Do
do
it
it?
right
Have
now.
the same
She's
problem?
a, no, she's a Oba. Loves the distance.
I love it.
It's
I
urgent.
finally learned how to
It's very
use
Well,
this.
it's the whiteboard on the
Same way.
desktop, but you
I'll
get to
take
save
the
everything
runner.
on your computer, not on here.
But I'm saving it here, so.
I know, but.
Yeah, but you're saving it in here. This is, it doesn't have a lot of storage.
I can see that, it's shutting down.
It's the same process, it's just saving it in a different place.
Can y'all come by 1:30 and show
It'll
me?
have more features.
Just, and it don't have to be today, it can be tomorrow, whenever y'all get time.
It'll be today.
All right, I'll be here, appreciate it.
Sorry, I tried.
Hey, I'll take gutter turkey in for you, just do it now.
One of them leaves right
In that case, you gotta do it
That's
now
the
too.
best
You
leave
gotta
ever
do
seen
it.
in my life.
be a lead, so.
She from Horse Head?
He's from Brantley, or close to Hoboken, close enough.
Appreciate it, guys.
Coach here in Mobile.
All right, where we at?
I ain't known for taking gutter.
Number 3? All right, so what I was getting at, you gotta start from the back and work your way to the front, Matthew. You can't do the amplitude first, you gotta do it last. So this is the hardest one. All right, y'all don't let me mix up Kaylin and Harlan right here. We've gotta make this a period of 1 pi, okay. Our first line, the length of it is 2 pi, right? Harlan, that's 1, 2, 3, 4 spaces long. They're saying this problem can only be pi, which is from 0 to pi is 2 spaces long. So I've got to shrink this thing down to 2 spaces. What you do is keep the left side like it is, take the right side and just squeeze it in. So I'm going to start it here, and I got to end it here. So look, I'm going to go there, there, there. Like that.
Is this the color one?
No, this is not the color because this is not the last one. You got to work your way right to left, so after I do the amplitude, that'll be it. All right, did I say that where y'all could understand? All right, so when you squeeze it, keep the left side where it is, take the right side and just squeeze it in half. Does that make sense?
Didn't mean you gotta work the
Now we still got to do the amplitude, which y'all should already know how to do.
dotted line.
All right, no, dotted lines when you go location change up or down. We don't have to do that. So amplitude is just where you multiply. So Matthew, keep these 3 the same because they're on the x-axis. You never move those. And what do I do with an amplitude of 2?
Move it up.
Instead of go up 1, just count up 2. There, and count down 2 there. And it just kind of stretches it out.
When did we write the?
When you're doing amplitude, you count from the axis.
You count from the x-axis.
You do that every time?
Every time. The only time you wouldn't, Hayes, if we had a dotted line, like if our location change was up 3 and we drew a new dotted line, that's what you would count from. But that's your new x-axis because you moved it up. And again, some of you may want a new color, an extra color. I like to draw my dotted lines in a different color. You good?
Alright.
You ready? All right, so 1, 2, and 3 were meant to be easy. 4 and 5 are a little bit harder because I'm going to make you do 3 changes on one problem. All right, so let's go to 4. On 4, we got to draw cosine. Okay, what does it look like? Handlebars on a bike. Don't forget that. All right, so I'm not happy with that. All right, so that's where we are. Now, you guys go through and find the 4 answers for the new problem. Got a place for you to write your answers. And I'm pretty sure this time we're going to have to make 3 changes.
What'd you say do first?
All right, you got your 4 answers right here, Harlan?
No, I don't know.
All right, go ahead and find your 4 answers. I'll wait on you. You should be able to do that. That's what we were doing on the chart, man. That's easy.
You're gonna ask me, that's what I
Just fill in the chart, find your 4 answers. So we got 1, 2. Now we got a phase shift because it's got parentheses. Flip the sign on this and it goes on top. So you'll have negative pi on top, divided by 1. Negative pi, 1, negative pi. No. Make it negative. All right, let's find our 4 answers. All right, amplitude is 2, period, 2 pi. Now look, that doesn't change. It was already 2 pi, right? We're not going to have to do anything with that. There is a phase shift on this problem. What is it? Negative pi. And there is a location change. It's up 1. All right, any question about those answers before we go any further?
Yeah, how'd you get negative?
All right, let me show you. Our formula is negative c over k for phase shift.
Okay, I got it.
And I put that on top, made it a negative divided by 1. Give me negative pi. All right, so question. What do we do first? Start on the back and work your way to the front. So guys, we got to do location change first. Okay, that means we got to move everything up 1. Make a dotted line in a color. That's going to be your new x-axis. Do that first. Now you go and you move every point up 1 space.
And you have to write this at every single thing. Like, you have to rewrite the,
Me?
you know what I'm saying? Like, do we have to rewrite it every single time?
What's he talking about?
Like,
You
the
talking about
draw
drawing
it,
the
like, you
lines
gotta
again?
draw it
Yeah,
every
you gotta
single
draw
time.
lines every time.
No? Okay, that's a good question. I've noticed over the years, some of y'all are smart enough where y'all can do like 2 steps at a time or 3 steps at a time. I'm fine with that. But you better know what you're doing. Because I'm not giving you any partial credit if you do it that way. I'm better doing it 1 step at a time. Move everything up 1 here. It's really the only way I can teach it anyway. All right, so when I moved everything up 1 spot, I got that. And I got my dotted line. Remember, you're going to have your dotted line to count from later. So make sure you draw your dotted line. All right, so next is the easy one. We got to do phase shift. Remember, that's just when you shift it left or shift it right. Where do we shift this one? It says shift it to negative pi. So look, we're going to take this graph in green, and we're just going to slide it over to pi. Negative pi, I'm sorry. So it'll be here, 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 here. There you go.
And when is this due?
You know, I was saying Thursday. I just don't know if we'll be ready
It
Thursday.
better not be.
Why
No,
is
we're
it
not.
that high?
We'll do it after spring break.
Well, that's not even there.
That will
That's
fill it all.
all.
All right, anybody got a question about my blue graph up here before I go any further? So what I did, I just slid it back to negative pi. Took this side and I just slid it back. Instead of starting it at 0, I moved it back, now I'm starting it at negative pi. But it's the same graph, it's still 4 spaces long. Somebody had that question a minute ago, they said, what about the period? Well look, it had to be 2 pi. 2 pi is 4 spaces long. Make sure it's still 4 spaces long. 1, 2, 3, 4. Yeah, still 4 spaces long. All right, now the last step, we do the amplitude. So now this is our last step. We'll do it in a color. And you guys should be able to do it. The ones on the x-axis, we keep them. The ones on the dotted line, they don't move, remember?
I just messed up on my colors.
It's
so I'm
okay,
just gonna
don't worry
scratch
about
it out, but I got the right
Nah, don't worry about
answers.
it. So now, Matthew, I got to count up to, where do I count from? Count from the dotted line. Y'all don't count from the point that was already there. So it's 1, 2. 1, 2. Whoops, hang on, I messed up. 1, 2. There we go. All right, new people, what you think?
I'm good. I think I'm good.
All right, flip it over. You got a number 5 on the back. See if y'all can do anything with number 5. Number 5 is going to have 3 changes, just like number 4. Hopefully, surely I wouldn't give you one on the test with 4 changes. That would be pretty unfair. 3 changes is enough.
Hey, did you say if it was like 2 of the same on top, so it'll just equal 1 on the bottom?
Show me what you mean. Oh yeah, if the tops are the same, the bottom's gotta be the same. Yep.
It's just 1?
Yep. All right, so on number 5, we know y'all got to draw your graph or sign, and feel pretty confident that y'all know how to do that. All right, there's your graph or sign. All right, y'all write your 4 answers now for your new problem. You already got them? Go ahead and find the amplitude, the period, the phase shift, and the location change. It's good stuff.
Silly.
All right, so amplitude I got 3, period I got pi. What's y'all's phase shift on this one? All right, I'm hearing y'all say 2 pi. We good with that? Location change is not 1. All right, I can see I messed up a little bit on this problem, didn't I?
Yeah.
All right, first thing we're going to do is our phase shift. Now, what does it mean if our phase shift says 2 pi? It means take your graph, slide it all the way out, and start it here. I don't have enough room on my graph. Do y'all have enough room on yours? All right, well, let's add a few more spaces in. So add 1 there, 1 there, and 1 there. All right, so the next one is 3 pi, then 7 pi over 2, then 4 pi. That should be enough, I think. Or we could have said 3 pi and 3.5 pi. That would probably be easier.
We got to change it over.
Hold on, we're not changing anything yet. We're just drawing our graph a little bit longer.
No, we don't have to move it that way.
You got to move it to positive, slide it down to 2 pi. All right, so now, here's the deal. Instead of starting at 0, it says we've got to start at 2 pi. So I'm going to take this graph and just slide it down and start it here. And I'm going to draw the same exact graph I had. It's just down there now.